Okay, today we're talking about mixed expressions. What does that sound like, mixed expression? Mixed what? Mixed emotions? Mixed fractions. Fraction. You guys remember mixed fraction? Something like this? Mixed emotion. Okay, so if I ask you to simplify 2 and 3/4, that's mixed fraction. Wait, isn't this already simplified? You could kind of say that, but really, when you simplify fractions, it's best we say it's simplified when it's an improper fraction. Okay, so how do anybody know what this is? Yeah, Laura? Yeah, what's that equal to? It's an improper fraction. 11/4, easy. Why am I even asking this question? Because when you do 11/4, how did you get 11/4? You took a shortcut, didn't you? You did what? 2 times 4 and then added 3. But when you think about it, that's not any of the algebraic rule that we learned. You don't multiply 2 and 4. Why do we do that, you know? But that's a shortcut. So let me show you how it's done, what it means really algebraically. Oh, you see it already? No. Oh, hold on. Okay, what does 2 and 3/4 mean? What operation is in between 2 and 3/4, by the way? So yeah, I know that a lot of you could do this in your head, but let's do this algebraically. Madeline. You think it's multiplication. How many people think it's multiplication? Remember when you have two numbers? Okay. Because if it is multiplication, then you don't get 11/4. Because if it was this, if I had parentheses around it, then it's multiplication. Okay? Then if it was multiplication, then you get, what's the answer? It becomes 3/2. See? 2 and 3/4 is not 3/2. Isn't that right? So be careful. What operation then is between? Yes, John? It's addition. It means 2 plus 3/4. Okay, so be careful. If I had parentheses or something, yeah, then it's multiplication. If I don't have anything and I get a number and a fraction next to each other, right? It really means addition. Okay. I know why you're thinking multiplication, because you're thinking about something like this, right? When there's two numbers together, right? But yeah, if you have mixed fraction, it's really addition in the middle. And you will see why it becomes 11/4, because how do we add these two numbers together? Yes, Lara? 2/1, right? So, Caroline, what do I need to do? If it's 2/1, could I add them right now? No. So, Caroline, what do I do? You could do it that way, or 2 is really 2/1, so your denominator is really what? For 2, guys? 1. So what do I need to multiply top and bottom of this fraction by? John? I mean, Anais? 4. So isn't this what we're doing really? Do you see what so remember when we add fractions, we need to make sure that the denominator are common. And isn't this kind of nice? When the denominator is 1, it's easy to kind of match them up. You know what I mean? If one of them is 1, you just, right? LCD is really easy to find. Would you not agree? Okay, so that's how we get 11/4. And yeah, a lot of you did this shortcut in your head, but right, you're not really using any algebraic steps here. You're just using a shortcut, right? No, I'm just kind of making a point here. I don't want you to, you could do the shortcut, but remember this is what you're doing. Remember that the operation between 2 and 3/4 is really addition. Okay, let's do example 1b. Okay, this one is kind of interesting. Even though it's very straightforward, and a lot of you have already seen this before. Okay, let me go to example 2. So look at example 1b now. Now I have negative 4 2/3. Okay, so how many people think they know how to rewrite this as an improper fraction? One person? What do you think, Mary? I mean, Elizabeth?
Negative 11 or no, wait. Negative 13. 14 over 4.
Negative 14 over 3. Okay, so one person thinks it's negative 13 over 14. I mean, negative 14 over 3. Anybody have a different answer? Taline, what do you think? You think it's negative 10 over 3? Okay. How many people think it's, anybody have a different answer? What do you think? You think it's negative 11 over 4?
No, sorry.
Yeah, it's 2/3. Okay. So how many people think it's negative 14 over 3? Raise your hand. How many people think it's negative 10 over 3? Emily, why do you think it's negative 10 over 3? Oh, so when you do the shortcut, right? You do negative 4 times 2, which is negative. Wait. But that's wrong. Turns out. It is negative 14 over 3, guys. It's not negative 10 over 3. Okay? Do you see why when you take a shortcut, it's kind of, you can kind of make silly mistakes? Okay? Because like half of you thought it was really negative 10 over 3. Be careful, it's not. Yeah? Hmm? Okay, so one way to think about this is this. If you have negative 4 over 2/3, what is that as a decimal? Yeah. Yeah, it's not negative 4.6. It's negative 4.666 forever, right? So this is negative of 4.6. Isn't that right? So if this became negative 10 over 3, what's negative 10 over 3 as a fraction? It's not even close to 4, is it? It's like 3 point something, isn't it? You see what I mean? So it can't be negative 10 over 3. Does that make sense? But if it's negative 14 over 3, then yeah, it becomes negative, right? 4 and 2/3. So this really means this. Negative, parentheses, 4 and 2/3. Right? Isn't that what it means? It's negative of that whole fraction, 4 and 2/3. You get that, Tony? Does that make sense? So then you can think of this as, okay, that's really 4 plus 2/3, right? But it's negative of the whole thing, right? Therefore, you get negative. So if you think of it this way, negative 4 over 1 plus 2/3, that's wrong. You see what I mean? Okay, you have to have parentheses around this. You see the difference? I'm talking about negative of this whole.
If it's a negative, you subtract it?
No, if it's negative of the whole 4 and 2/3. You can think of it as like there's a grouping symbol that's kind of hidden there. You know what I mean? It's not negative 4 only. It's negative 4 2/3. The whole thing is negative. You know what I'm talking about? So there's like a hidden grouping symbol if you think of it that way. If you like to think of it that way. Do you understand what I'm saying, guys? Okay. So therefore, then of course if you have this, you get then what's the answer? 4 over 1. What do I need to multiply 4 over 1 by? Judy? 3 over 3. So I get 3 as my denominator. Again, isn't this easy when one of the other fraction has a denominator of 1, right? It's easy to make common denominator, least common denominator. So there you go. You get negative 14 over 3. Okay. And in shortcut, question?
What happens if you have a variable?
We'll get there in a minute. That's actually, okay. So for shortcuts, you could think of this as negative 1 times 4 and 2/3. You know what I mean? And then so you could just kind of think of 4 and 2/3 first. 4 times 3 plus 2. So you get negative 14. Stick a negative in front of 14 over 3. Yeah, that's what you should be thinking. Okay. I bet that's what you've been doing. But when I ask that question, you kind of think a little too hard. You know what I mean? But you have to really understand that the negative 4 and 2/3 is really negative of that whole 4 and 2/3. Okay. So there's a hidden parentheses there. Okay. Any question? So maybe I should do this in red. See? It's really there. Okay. Move down more. Right? Good? Okay, so these two examples that we did, 2 and 3/4, negative 4 and 2/3, these are all called mixed fractions. These could be also called mixed expressions. Okay, fraction. Because by definition, mixed expression is, anybody want to guess what mixed expression might be? How they define it? It's kind of like mixed fractions, but now instead of just all numbers, you could have variables in them. Mixed expressions is nothing more than, anybody want to guess? No? It's basically this. Sum or difference of a polynomial and a fraction. That's what a mixed expression is. If you have a polynomial plus another, or subtract another fraction, okay, that's what a mixed expression is. And I wrote down, these are easy to come up. These are easy to deal with. I'll show you why in a minute. Does anybody really see why it may be so easy to deal with these? Well, compared to what we did last time, like adding and subtracting fractions, mixed expressions are a bit easier. Does anybody know why they're a bit easier? No, you could subtract. Yeah. You don't have. Oh yeah, you still have to factor. So you could have expressions that are factorable. Okay, let me give you an example. Let's see whether you could figure this out. Okay, so here is a mixed expression. As you can see, I have a polynomial. This happens to be a monomial, 3t minus 2 over t. It's a fraction. Why do I say this is, this is kind of easy to deal with, instead of like just adding and subtracting fractions? Right?
This is just 3t over 1.
Yeah, it's 3t over 1. One of the fractions gonna have a denominator of 1. It's always nice to have a denominator of 1. Yeah, so what are you gonna do, guys? Anybody? I know you said it, but what am I gonna do? This is 3t over 1. Do you think it's a good idea to change it to addition? Yeah, okay. Always do that. It just makes it easy. You don't make silly mistakes. So what are you gonna do? It's 3t over 1, and the other one has a denominator of t. What are you gonna do so that you get a common denominator? What's the common denominator? T. That's the LCD, by the way. That's the least common denominator. Thomas, what are you going to do to?
Multiply 3t and 1 below it by t.
Yeah, just multiply 3t over 1 by t over t. Exactly. So you get a common denominator, right? Okay? So everybody go ahead and finish up. What do we get? Darren, what do I get when I do this?
You get 3t squared minus 2 over t.
That's right. 3t squared minus t over t. There you go. Right? Isn't that nice? So when you have mixed expression, it's easy to get a common denominator, right? Least common denominator. Because one of them is going to be 1, right? Does that make sense? By the way, I've seen people do this. Hey, at this point, like when you multiply top and bottom by t, right? Didn't I say simplify all the time, right? Always simplify. So people say, oh, why don't we cancel out t and t?
That doesn't work.
Why don't we do that? And then, Emily?
Because you can take away t before.
Yeah, what? No, no. So people say, oh, shouldn't you always be simplifying? So why not cancel out t and t over here? Why don't we do that? Yeah.
Oh.
No. See this t and this. So some people say, let's do this. They say, oh, Mr. Huang said always simplify. So what people do is they say, oh, I could see something I could simplify. So they do this. They say, oh, why don't I do this?
Oh no.
Why don't we do that?
You would have a.
Kristen?
You don't have a common.
Then you don't have a common denominator. You're back to what you started off with. You know what I mean? And you go back and forth. I mean, it doesn't get you anywhere. You know what I'm talking about? Why do we multiply top and bottom by t to start with? So that we have, yeah, common denominator. You don't want to cancel it out, when you already have common denominator. Does that make sense? Okay. Anyway, may I go to example 3 then? Okay. All right, go ahead and try example 3. And it's very similar to the one we just did, except now we have binomial in the denominator. Okay, go ahead. I'll give you some. Do you think it's a good idea to change it to addition? Always is a good idea. Go ahead, everybody try. Okay, so what do I do? Who could tell me my next step? Okay, Andrew.
You have to change it to addition.
Yep, and tell me what's right.
Do x over x minus 1 plus 5.
5 over
negative 5
plus negative 5, right? Plus negative 5 over 1. It's exactly right. And did you guys all multiply top and bottom by x minus 1? Okay, who thinks they have the... Malia, what'd you get as your answer? Okay. So 4x. So when you do that, did you guys remember to distribute this negative 5 to x plus negative 1?
Yeah.
Did you all write why do I have so okay. Did you all write this? I don't need any of these. Okay. So x plus negative 5x plus 5, right? Then did you all get negative 4x plus 5 over x minus 1? Easy?
Yeah.
All right. Should we try example 3 then?
Yeah.
All right, good. Example 4? Thank you. Okay, here's example 4. X minus 3x minus 1 over x minus 2 plus 5 over x minus 2 is t.